Assalamu alaikum, my dear cadets of class 11. I welcome you all to my online physics class. You know it very well that we are passing very tough and rough situation due to corona pandemic. So you are not able to stay at this college. That's why this online effort. I think this online effort will be very much helpful for all of us. Before starting my today's discussion, I would like to introduce myself. This is Mr. Kamrujaman Khan, lecturer, Department of Physics, Borishal Cadet College. This class for class 11, subject physics, chapter 3 of first paper, and it is symbolized as dynamics. You know it very well that this is the continuation of my previous class, so I will discuss today projectile motion. In my previous class, I have discussed about linear motion that was related about relative motion. That was relative motion. Okay. Okay, boys, no more delay here. Let's start my today's class. Projectile. Today's topic is projectile. Now I am going to start projectile. Let's enjoy this video before starting my today's class. I think this video will very much helpful for getting this topic. Please.
A car moving a horizontal motion along a straight path, and a stone falling from vertically from a third floor building to the ground. But now how about if an object experiences moving along horizontally at the same time vertically? This kind of motion is called projectile motion. In this video, we will learn the concept of a projectile motion. Suppose you are firing a cannon at some angle. The cannonball will follow a parabolic path during its flight before it reaches the ground. We will try to understand the movement of the cannonball. First is its velocity. Initially, the cannonball has initial velocity. This initial velocity can be resolved into its x direction as and y direction as. This means that the cannonball is moving upward while moving to the right. When the cannonball moves upward, the velocity in x direction is constant or the same as the value of, while the velocity along y direction is approaching to 0. When the velocity along y direction is equal to 0, the cannonball is in its maximum height from the ground. The cannonball continues its parabolic path. During its flight, the cannonball experiences a motion going downward while going to the right. This time the velocity along x direction is still constant, but the velocity along y direction is approaching to the value same as the initial velocity along y direction, but in negative value to indicate that it is going downward until the ball reaches the ground and the velocity is 0. To sum up everything, the velocity along x direction is constant and the velocity along y direction is changing with respect to its position. Initially, the velocity along y direction is when the cannonball reaches the maximum height, the velocity along y direction becomes 0, and the velocity of a cannonball before it reaches the ground is equal to the initial velocity along y direction, but in negative value.
Okay, my dear boys, after observing this video, I think you can get my today's topic. Okay, this topic is related about the projectile motion. So no more delay. Today's topics is projectile. Learning outcomes of my today's discussion. By the end of my today's discussion, cadet, you will be able to analyze the motion of projectile, and you will be able to the application of the concept of projectile. Today's key points of my discussion: projectile, trajectory, horizontal range, time of flight. Okay, projectile. What is projectile? If you go to a stadium to enjoy cricket game, then you will see that the cricket ball thrown from the boundary is seen to be ascending first and then descending to the ground in a curved path. Similar phenomena are observed in case of motion of bullet fired upward from a gun, motion of arrows, bomb thrown from plane. In all cases, same type of trajectories are observed. These types of curved motion is called projectile motion, and the path of this projectile is trajectory. The path of this projectile motion is called trajectory, and it is also a parabolic path. Okay, what is projectile? If a body is thrown obliquely with some initial velocity, if a body is thrown with somewhat initial velocity, then allowed to move under the action of gravity alone is known as projectile. But the concerning point is to this body, it must be thrown obliquely. This body must be thrown obliquely. If you thrown this body vertically, then it will not be defined as projectile motion or projectile. Okay. If you get projectile motion, you have to throw a ball obliquely. So if we observe the path of the projectile, we find that the projectile moves in a path which can be considered as a part of parabola. Such as motion is known as projectile motion, and I think the more trajectory of this projectile will be very much clear after some time. So let me allow some time to make you clear about the projectile motion. Okay, let's see this graph. And it is very similar to my short video. Okay, here you are throwing a ball or somewhat or some type of body with a somewhat velocity, and this velocity is called initial velocity, and this velocity here is being resolved into two components, that is along x-axis and y-axis. That's why it is called v naught x and v naught y. At every point except the maximum height, except the point of maximum height, you will get two component of velocity. Okay, here at the point of maximum height, the velocity that is along y-axis will be 0, and vx, that is along x-axis, there will somewhat velocity. And now the direction of this velocity along Vy will be reversed, and Vx will be same. And here, this is our terminal point and this is our initial point. Between this, or in between terminal and initial point, this ball will be covered somewhat velocity, sorry, somewhat distance. This distance is called horizontal range. This distance is called horizontal range, and the time required to reach the maximum point, is called ascending time, and this time will be equal to reach the ground. Equal to reach the ground. So the ascending time and the descending time will be equal, and these two makes a single time, that is time of flight. Time of flight means required time to reach the maximum height and to reach the ground. Okay, and this portion is called maximum height. Okay, the distance covered along x-axis is defined by x, and the distance covered along y-axis is defined by y. Okay, let's see. Equation of motion of a projectile. Let us suppose this is our origin. From here, a body is thrown with a velocity that is v naught at an angle theta naught. So you are getting vx0 and vy0. At any point, you will get this two component of this velocity except our maximum height. Let's see. Okay. The change of motion along y-axis depends on the acceleration along y-axis. Okay, but there is no acceleration due to gravity along x-axis. There is no acceleration due to gravity along x-axis. Even there is no linear velocity. There is no linear acceleration along x-axis. So let's see. Acceleration along x-axis, that is defined by ax is 0, and I will make this equation, my dear boys, I will make this equation by using our linear equation. You know it very well that x is equal to vt. X is equal to vt for our uniform velocity. Okay, along x-axis, this equation becomes, you know it very well that Ace is equal to ut, Ace is equal to ut or v naught t plus half at square. Okay, now I am going to transform this equation into x is equal to vt. Our covered distance along x-axis, that's why Ace is replaced here. Ace is replaced here by x. Ace is replaced here by x. So this is x, and along x-axis you are getting velocity component v0 cos theta, v0 cos theta, v0 cos theta, and t. Okay, but acceleration along x-axis, that is ax, is 0. So this term is 0. This term is being neglecting here. So we are getting x is equal to v naught cos theta t, v naught cos theta t. Okay, from this equation you can find very easily t is equal to x over v naught cos theta. T is equal to x over v naught cos theta. Okay, my dear boys, what am I going to deliver? It's our concern. What am I going to deliver? I am going to find out the distance or height. I am going to find out the distance or height along x and y axis at any time or at any instant of time. Okay, let's see the displacement along y axis. Okay, our equation Ace is equal to ut plus half a t square. Okay, Ace is replaced here by y because we are finding our displacement along y-axis, and u or v not replaced here by v naught sine theta, v naught sine theta, boys, v naught sine theta, because we are getting component of velocity along vertical line. So v naught sine theta and t. Okay, now half a t square, a is replaced here by g because upward and downward there is acceleration due to gravity, not linear acceleration. So this is g. Okay, this is our equation, and let's see. Y is equal to v naught sine theta t minus half gt square. Y is equal to v naught sine theta t minus half gt square. Now I am putting this value here, t for x divided by v naught cos theta, t for x divided by t for x divided by v naught cos theta, that is x divided by v naught cos of theta. So from this you are getting tan theta x, and similarly I am putting also here the value of t and getting gx square divided by 2 v naught square cos square theta. My dear boys, now let tan theta is equal to b. Now let tan of theta is equal to b. Tan of theta is equal to b, and this c over 2 v naught square cos square theta is equal to c. So we are getting y is equal to bx minus c x square. Y is equal to bx minus c x square. This is the equation of parabola. This is the equation of a parabola. So the path or trajectory of projectile motion is parabolic. It is our very burning questions. What will be the nature of the trajectory of projectile? Okay, you are getting confused by hyperbola or ellipse or parabola. Okay, but you should keep it in your mind that this equation always becomes for this equation always becomes for parabola. Okay. Okay, now I am making you clear. Now I am making you clear what is the nature of the equation of projectile. Okay, let's say when you were throwing a ball, this ball covered somewhat distance along this path. Never. Along this path. No, this is not like this. Okay, next parabola. Yes, this is the nature of your thrown ball. Okay, this is the nature of your thrown ball, and this is not the nature of your thrown ball. So this is obviously parabola. Okay, what is parabola? Now I am making you clear, or I am making you very easy about the concept of parabola by using a video. Let's see my video to make you clear for the parabola.
In this session, we've understood the concept of napped cone formed by the intersection of a plane with a double napped cone. To summarize, the curves formed are the circle, the ellipse, the parabola, and the hyperbola.
Okay, my dear boys, I think your concept is very clear about the nature of ellipse, circle, and parabola. Okay, this is the path of parabola, and this is hyperbola, and this is for ellipse. So this is not like our parabola or like our projectile motion. So the motion of projectile is obviously parabola. The trajectory of the motion of projectile obviously parabola. Okay. In case of projectile motion, the expression of required time, that is ascending time or descending time, maximum height, time of flight, horizontal range, and maximum range. Now, I am going to find out some important parameters in the case of projectile motion. Okay. By this time, it is very much clear to all of you that we are getting two components of our initial velocity, okay, and we are getting maximum height for projectile motion. So now I am writing the equation, that is v is equal to u plus at, v is equal to u plus at. Okay, this equation becomes 4. This equation is transforming. This equation is transforming or is being transformed for the case of projectile motion. Okay, now this is vy because I am going to find out the velocity along y-axis, and so this u becomes v naught sine of theta, and here minus gt, here minus gt because this is along y-axis. So but the velocity at maximum height y is equal to 0, vy is equal to 0. You know it very well that at the maximum height, the velocity along y-axis, must be 0. Otherwise, this ball will never come down at the ground, Now, putting the value of Vy is equal to 0, we are getting V naught sine theta minus gt is equal to 0. And from this, we are getting ascending time or descending time T or TD is equal to V naught sine theta over G. V naught sine theta over G. Okay. Now for maximum height, let the maximum height, you know it very well that y is equal to or h is equal to ut minus half gt square. Here h, that is small h, is replaced by capital H because it is maximum height, and from this we are getting h is equal to v naught square sine square theta divided by 2g. V naught square sine square theta divided by 2g. Sine square theta divided by 2g. Now time of flight. Time of flight, this is the combination of ascending time. This is the combination of ascending time and descending time, and it makes capital T. This is called time of flight. Let the time of flight T. T is the taken time from the point of projection and return to the ground. That is capital T. Vertical displacement at that time T. Y is equal to V naught sine of theta minus half gt square. Let the time of flight be capital T. In time capital T, projectile returns to the ground. That's why y or h is 0. In the time, that is time of flight, projectile must touch the ground. Projectile must touch the ground. That's why h or y becomes 0. Now putting this value, we are getting t is equal to 2 v naught sine of theta, 2 v naught sine of theta divided by g. Okay, this is our most important equation for mathematical calculation. So you should try your level best to remember this equation. Horizontal range. Horizontal range means the covered distance by the projectile along y-axis, along x-axis. So you know it very well that x is equal to vt, but here x is equal to vt, but here x is replaced by capital R, and v is v naught cos of theta and t. This is our total equation for horizontal range, but this t is not capital, this t is not small t, this must be capital T. This must be capital T because it is happening for time of flight. It is happening for time of flight. Now we are getting this R is equal to V naught square sine 2 theta divided by Z by the putting of T, capital T, by the putting the value of capital T, by the putting the value of capital T. Okay, this is our equation for horizontal range. This is our equation for horizontal range. Horizontal range means if this is the trajectory of projectile, so R becomes this distance. R should be this distance. Okay, this is our R. Now I'm going to discuss about the maximum horizontal range. When you will get maximum horizontal range? Obviously, it is very much clear that when you will get 2 sine of theta as 90, that is sine of theta becomes 90, then you will get r is equal to v naught square over g, and it will be the maximum horizontal range. It will be the maximum horizontal range. Let's see. Maximum range for sine 2 theta is equal to sine 90, 2 theta is equal to 90, and theta obviously 45. So you will get maximum horizontal range for angle 45 degree. Okay, my dear boys, I think I have covered all important parameters for horizon, for projectile motion, for projectile motion. So let's see some mathematical problem, and I think this problem will make you clear for the application of projectile motion, for the application of projectile motion. Okay, let's see. Okay, boys, about the discussion or before the discussion of projectile related mathematical problem or mathematical problem related projectile, I would like to discuss some important equation that I have elaborated here. Y is equal to x tan theta minus g x square over 2 v naught square cos square theta cos theta. My dear boys, look at this equation at a glance. Look at this equation at a glance. Okay. Now our mathematical problem. A body is thrown in the space making an angle 60 with the ground at a speed of 49 meter per second. Determine the following parameters. Maximum height. You know, for the determination of maximum height, A is required. Capital A is, the equation of capital A is like that. By the putting of this, or by placing this equation, you can get very easily the value of maximum height. Okay. Number B, horizontal range and maximum horizontal range. Horizontal range, that is, this equation is applicable for B, V naught square sine 2 theta divided by Z. Okay. And maximum horizontal range, this is V naught square divided by G. V naught square divided by G. Okay, by these two equations, you will get, or you will be able to determine the value of horizontal range and maximum horizontal range. Number C, time of ascent and descent and time of flight. You know it very well that ascending time and descending time is very equal. So TA is equal to TD is equal to V naught sine theta divided by G. By this equation, you will get ascending and descending time, and time of flight, capital T2 V naught sine theta divided by J. So by this equation, you will get the value of time of flight. Okay, horizontally projected projectile. Okay, now I'm going to discuss about the horizontally projected projectile. I think it will very easy for you because you have discussed or you have shown the equation for projectile that is thrown obliquely. Okay. Equation of path, that is, let us suppose you are somewhat height, you are at somewhat height, or you are at the roof and you are throwing a ball horizontally, that is, it is similar here. Let us suppose you are standing here and you are throwing a ball along this horizontal line. Okay. After covering some distance, the path of this ball will be like this path will be like this, okay. So now we are going to find out the equation of horizontally projected projectile. Equation of path: x is equal to v naught t plus half a t square. Okay. If or since this projectile or this body is projected along the horizontal line, so theta is 0. You must be remembered that for the horizontally projected projectile, theta must be 0. That's why you are getting x is equal to v naught cos of theta, that is cos 0, and multiplied by t. So this x becomes v naught t. That's why we are writing here x is equal to ut, and from this t is equal to x over u, that is v naught t. Okay. And for y is equal to ut plus half at squared, this equation is written here. Y vy euy becomes v naught sine of 0 and t. Since sine of 0 is 0, that's why we are omitting this and we are writing this y is equal to half gt square. My dear boys, look at this equation. This is very similar to the falling body. This is very similar to the equation of falling body, that is h is equal to half gt square. H is equal to half gt square. Okay. So for the case of horizontally projected projectile, a is always half gt square. A is always half gt square. Okay. And putting the value of t in equation 1 and 2, we are going to see what we can get. Okay, y is equal to half g into x divided by u whole square. Now y is equal to half g divided by u square into x square. This is the path of projectile and it is the nature of parabolic equation. It is the nature of parabolic equation. So in the case of in case of horizontally projectile motion, we'll get different equation for time of flight. Let's see what is our time of flight. What is our time of flight in case of horizontally projected projectile? Okay, my dear boys, the amount of time of a projectile spends in air is called time of flight. Okay, for this y is equal to ut plus half at square. Here a is equal to v naught sine 0 t. That's why we have written here 0, and this time small t is replaced here capital T because it is related to time of flight, and this is half gt square. From this equation I'm getting very easily capital T is equal to root over 2 2h divided by g, 2h divided by g. Boys, it is very similar to the equation of falling body. So from this equation, h is equal to half gt square. This t is replaced here capital T. Okay, this t is replaced here capital T because it is related the time of flight. That's why we are getting from this equation t capital T is equal to 2 root over 2 h divided by g. T is equal to, that is capital T is equal to root over 2 h divided by g. Horizontal range. The horizontal range, that is x is equal to vt. Here you are getting r is equal to v naught cos theta 0 t, and t is capital T because you will get horizontal range for the time of flight. And now r becomes u into root over 2h divided by g, u into root over 2h divided by g. and the velocity at an instant. It is very important question for the projectile that is thrown obliquely and as well as horizontally. Okay, Vx is equal to, you are getting this equation from this linear equation, V is equal to u plus at. Okay, V is equal to u plus at. So V is equal to u plus at. Now along Vx, u, that is V naught cos theta 0, and this term is 0. Okay, so we are getting this, that is Vx V naught cos 0. So Vx is equal to only V naught. Vx is equal to only V naught. Okay, now for Vy, this equation Vy V naught sine theta, that is sine 0, u plus, that is u plus at. Okay, this is a, this a is replaced by g, this a is replaced by g, but this a is replaced by g, and it is happening towards the ground, it is happening towards the ground, it is happening towards the ground. That's why I have used plus sign, that's why I have used plus sign. But in case of obliquely thrown projectile, I have used here minus sign. Okay, so from this equation you are getting Vy is equal to gt. Simply Vy is equal to gt, and this is our Vx vector, and this is Vy vector. From this we are getting our resultant value V is equal to root over Vx square plus Vy square. Okay, now after putting the value of Vx and Vy, we are getting V is equal to root over u square plus gt whole square at an angle of alpha is equal to tan inverse Vy divided by Vx, because if you if you think here this is thrown by angle theta, and here you can find a triangle. From this triangle you can write tan theta is equal to Vy divided by Vx, Vy divided by Vx, Vy divided by Vx. And from this you can write tan theta or alpha is equal to tan inverse Vy divided by Vx, Vy divided by Vx. Okay, my dear boys, I think I have covered up all the important parameters for obliquely thrown projectile as well as horizontally thrown projectile. Okay, now let's see some mathematical problem related horizontally projected projectile. Horizontally projected projectile. Okay. Okay, boys. A body is thrown downward from the roof of a building of height 170 meter at an angle of 30 degree. At an angle of 30 degree, its initial velocity is 40 meter per second. Its initial velocity is 40 meter per second. Okay, you have to find out these following quantities. How long will it take to strike the ground? How long will it take to strike the ground? And determine the horizontal distance, and lastly at what angle will it strike the ground, at what angle will it strike the ground at first. How long will it take to strike the ground? You know it very well that the equation of horizontally projected, the equation of horizontally projected projectile is very similar to the equation of falling body, to the equation of falling body. So for this equation you can write very easily h is equal to half gt square, h is equal to half gt square, that is becomes h is equal to half g t square. Okay, or you can also use the alternate equation, that is y minus y minus y0. Boys, look at this equation, it is very complex for us. Please look at here. Y is equal to y0, y is equal to y0 is equal, y minus y0 is equal to v y naught, v y naught plus half plus half a y t square, a y t square. Okay, you are very much confused about this equation. You are very much confused about this equation. Now let's see. Y here, for y you will get 0. For y here you will get 0, but y 0, that is 1 centimeter. And you can think, how come you are writing, sir, how come you are writing this y is equal to 0 and y naught is equal to 170? Boys, look at here. When you are throwing a ball from this position, suppose after somewhat distance, this ball covered, after covering some distance, it will reach at point A. Okay. Yes. For this height, that is a point A is y, and that's why you are writing y is equal to suppose 170. Okay, but the ground position y0 was 0. Boys, for the ground position y0 was 0, but this stem that is shown here is very reciprocal of that case, is very reciprocal of that case. Okay, okay, let's see. Suppose you are already at somewhat height, that is y. You are already at somewhat height, that is y. So y is equal to 0. Okay. After throwing this ball will cover somewhat distance and touch the ground. So this is obviously y not. This is obviously y not. You can ask me why it is y not, because it is touching the ground, because this ball is touching the ground. That's why it is denoted by y0. It is denoted by y0. So y0 becomes 170. Y0 becomes 170. Okay. This is very much confusing equation. This is very much confusing equation. So I am trying my level best to make you clear about the application of this equation. Okay, and I think it will very clear to all of you. Okay, number B, determine the horizontal range. It is very easy. Determine the horizontal range. It is very easy because you know x is equal to v naught t. X is equal to v naught t. Okay, x is equal to v naught t. Here you will get v naught cos of 30, because this body is thrown by an angle or at an angle 30. Okay, and that is capital T. From this equation you will get very easily the horizontal range for the projectile that is thrown horizontally. Okay, and now at what angle will it strike the ground? At what angle will it strike the ground? Okay, it is obviously related to the equation that is I have discussed a little bit ago. That is I have discussed a little bit ago. Y minus y0. Y minus y0. Okay. That is, see the image. Let us suppose you are throwing this ball at this position. You are throwing this ball at this position. Okay, and after somewhat it will touch at point B. You have to find out at what angle will it strike the ground? At what angle will it strike the ground? Okay, if you find out the angle, you have to draw a tangent, and this angle is our concerning angle. So now it is very easy to find out. Now it is very easy to find out the theta, that is tan theta is equal to Vy divided by Vx, Vy divided by Vx. Okay, you have to find out Vy and Vx, then you will get, your equation, that is tan theta is equal to Vy divided by Vx. So V, at first Vy, okay, Vy, V naught sine, 30, okay, V naught sine 30. This equation is coming from V is equal to U plus 80, okay, U plus 80. Now for plus 80, A for G, and T, what is T? In our previous calculation, we have got the T. That is in our equation, in our question A, we have got T. Okay. So you have to put the value of T, and you will get Vy, and Vx is equal to V naught cos theta. Okay. V naught cos theta, that is cos theta means cos 30. Okay, and now you can get very easily theta is equal to tan inverse Vy divided by Vx, tan inverse Vy divided by Vx. Okay, my dear boys, that's all for today. I think I have covered up my today's discussion. Thank you. Okay, my dear boys, I have inserted here some sorts of questions, that is knowledge-based questions and comprehension or understanding level questions. You should try your level best to guess these questions and answer these questions. If you face any problem, please contact me, and I will always here to mention your questions, to answer your questions. Okay. And this is application and higher order or higher level questions. Okay, let's say this STEM and try your level best to solve this question. Some sample of MCQ are inserted here for the betterment of your understanding. Okay, let's see and try to find out the answer of this MCQ. Try to find out the answer of this MCQ. Okay, homework. This system is added here for your home task. Please try your level best to solve this CQ. If you face any problem, please tell me. Or if you don't have any problem, please solve these questions and send me through the email. My dear boys, if you have any query, please ask me. I will here to answer your all questions. I will here to answer your all questions. You know it very well that we are passing very tough and rough situation during this ominous cloud of COVID. You are not safe at the outside of your home, so please don't go outside of your home. Please stay home, stay safe, and pass quality time with your family members. So stay home, stay safe. Thank you for attending my class.